EET 114, Chapter 18, Section 5, Nodal Analysis. It says problem number 18 says determine the nodal voltages for the network shown below. So the first step is to identify the nodes. You have a node here and you have a node over here, and then this is your reference node, your ground node. Okay, that's where voltage is 0. So I highlighted them here. This is V1, V2, yellow and green. And then this is a nice block diagram showing this impedance here, which is these two impedances in series. And then this independent current source is shown here. And then another independent current source. And another impedance, which is this resistor here. And another impedance, which is these two impedances combined in parallel. So what the book did was show you what Z1 is equal to. It's equal to 3 plus J4, which is equal to 5 angle 53.13 degrees. Z2 is just going to be 2 of an angle of 0. Z3 is these two in parallel with each other, which is a 6 ohm resistor in parallel with an 8 ohm capacitor. So that's 6 ohm angle 0 in parallel with an 8 ohm angle negative 90. You do the parallel operation on them and you get this 4.8 angle negative 37 degrees. And then you have these two currents. You have I1, they're a little bit close here, but this is I1 right here. It's going down and it's 0.6 amps angle 20, and then I2 is going to the right, 4 amps angle of 80. So first thing you do is take your first node, V1, and do Kirchhoff's current law on it. So do we have any currents going into V1? Well, actually the first thing you do is label all your unknown currents as leaving the node. So they labeled I3 over here going through Z1. They didn't use I1 because I1's already taken. I2's already taken. So they called this I3 leaving here. And then the only unknown current, the other one, is going through Z2, and they called that I4 again because I2 was already taken. So now you do KCL at that node. None of the currents are going into the node. They're all leaving the node. This one's going down, down, to the right. So the sum of the currents coming in is 0, and the sum of the currents going out is just I1 plus I3 plus I4 plus I2. So then you have to write equations for each one of those currents. Well, you know what I2 and I1 are already. They're defined. I3 is going to be V1 minus 0 divided by Z1. Okay, because 0 is this node down here. They just didn't write the 0 because you don't really have to. Because it's going to end up being V1 divided by Z1. And then this current, I4, is V1 minus V2 divided by Z2. All right. So then what you want to do is simplify your equations and factor out your V1 and your V2, which they did. They skipped a few steps here algebraically, but you want to bring your V1 and your V2 out just like they did and combine like terms. And what they did here was they used admittance. So 1 divided by impedance, the inverse of impedance is admittance, or Y. So that's why they did that for simplicity. So you have V1 times Y1 plus Y2 minus V2 times Y2 equals minus I1 times minus I1 minus I2. So that's your node 1 process to get your first equation that you're going to solve with determinants. Likewise, you do a similar process for node V2. You've already defined this current's defined, and I4 is still going this way. So the only other unknown current you have is this I5 going through Z3. So the currents coming in to V2 node are I2 plus I4, and the currents leaving the node are I5. So they wrote that KCL equation right there. And then you simplify that. Again, I2 is what it is. It's already gotten a value. And then I4 is going to be, again, V1 minus V2 over Z2. You already defined that up here. And then I5 is going to be V2 minus 0 divided by Z3. So that's how they got that equation. And then furthermore, you do a more algebraic manipulation and you factor out your V1 and your V2. I don't like the fact that they should have put V1 first, put this term over here for clarity, but so this is they simplified it and put, again, they used admittances for Z2. 1 over Z2 is Y2, 1 over Z3 is Y3, and 1 over Z2 is Y2. And then what they finally did under this bar is they took this first equation and they copied it down here and they put it in the format that we like to see. And then they took this equation again and copied it down here and again rearranged a couple terms to put it in the format that we like to see. So the two equations now are in this form, where A is y1 plus y2, B is negative y2, C is minus the quantity of I1 plus I2. I just factored out that minus sign. D is negative y2, E is y2 plus y3, and F is I2. And then again, you use your determinants as so to solve for, you just take these variables and you put the solution in there to C and F in the first column, and then B and E go in the second column on the numerator, and then in the denominator it's just A and D and B and E in a column like form, and then you do your multiplication and subtraction. Same thing for V2. You put, this time you put C and F in column 2 and A and D in the first column, and then the denominator is the same in V2. And then you do your cross multiplication here, and then once you get your values on the top and bottom, you divide them. So they did all that work, putting all these values in. You have to calculate what y1, y2, and y3 are, and then you have to place all these values in for these values and do your multiplication and subtraction, and then divide the two, top and the bottom. You get, these are your answers that you get.